Today I'm going to talk to you about the difference between an LCD TV and an LED TV and which one is better. I'm going to start with the basic definition of LCD. It's an acronym for liquid crystal display. And the liquid crystal display television incorporates a few different elements. One of the main elements being polarization. Polarization is a property of certain waves that can oscillate. And those certain waves mainly being electromagnetic waves, which in this case is light. And we have a light source here, which creates an incident beam, which is unpolarized. And so the light source will create light waves in all different directions. So it's going to be vertical, horizontal, and diagonal. This incident beam from our light source is shot at a polarizer, which has vertical slits. This polarizer's job is to prevent all other waves coming from the light source going through this polarizer. The only wave to make it through is the vertical wave. Once the wave makes it through the polarizer, the wave is then polarized itself. It becomes a vertically polarized light wave. And it won't be able to pass through the second polarizer because now it is a vertically polarized wave and not horizontally. Now we're going to talk about the LCD pixel. The pixel itself is very complex, and when you combine it with many different other pixels, a picture can be displayed. In the TV, we have a backlight. In an LCD TV, the backlight are CCFL, which is a cold cathode fluorescent light. These CCFLs provide the light source for the polarization to happen. Within the pixel, there are two polarized panels, three separate electrodes, and 3 colored filters. The most important component of the pixel is the liquid crystal. Without the liquid crystal, we wouldn't be able to get the color. Now, as I said before, the polarized panel allows for a specific wave to pass through the first panel, and it won't be able to pass through the second panel because of the type of wave passing through here. In order to get the wave to go through the second panel and project the specified light, liquid crystals twist, channeling the polarized light to then pass from the first panel into the second. And the liquid crystals can twist because of electric current created by the electrodes. Since only the middle electrode is creating an electric current, the only color that will be visible from this particular pixel is red. An LCD screen is made up of millions of pixels who are doing this simultaneously to create the broad spectrum of colors that a TV can produce. And now we drop down to the LED TV. This is an LED TV in contrast to the previous television, which was an LCD TV. Now, the main difference between the previous television and this one is the backlight source. The backlight source in the LCD TV were CCFLs. The backlight in an LED TV is LEDs, which are light emitting diodes. Now, the process of emitting the picture is the same because it uses the polarization and the liquid crystal display. So it's an LCD TV at heart, but the change is in the backlight, giving it its more crisp color and defined edges. An LED is composed of a base, a diode, a glass or silicone lens, and a printed circuit board or PCB. An electric current is created by the PCB and flows through the base and across the diode to make it illuminate. LEDs were first discovered in the 1960s. And back then they were used to display whether or not a device or an instrument panel was on or off. My favorite example of an LED is right here in the Xbox 360 controller. Here we can see light emanating through the surface of the controller. This light is an LED light. Advancements in LED technology are continuing today. LEDs are more efficient, they last longer, create a brighter light source. They also allow TVs to be thinner than before, which is a high demand in the market today.